Solving arithmetic series. What do we mean by arithmetic series? If the terms of the sequence are added, the result is known as series. An arithmetic series is the indicated sum of the terms of an arithmetic sequence. If the sequence is given by 1, 2, 3, 4, 5, 6, 7, and so on, its arithmetic series will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and so on. Now let us derive the formula in finding the arithmetic series. So if the sum of the terms of a series is referred to as S sub n, or that is also the sum of the n terms of a series, that would be S sub n is equal to the first term, or a sub 1, plus the second term, or a sub 2, plus the third term, or a sub 3, plus so on and so forth, plus the last term, or a sub n. Or that is also the same with S sub n is equal to a sub 1 plus a sub 1 plus d. This a sub 1 plus d is also the a sub 2, plus a sub 1 plus 2d, which is also the a sub 3, plus so on and so forth, plus the a sub n. Let us say that would be our first equation. So given again our first equation a while ago, let us rewrite this into expanded form in the reverse order with decreasing d. That is, S sub n equals a sub n plus a sub n minus d plus a sub n minus 2d plus so on and so forth plus a sub 1. And let us say this is our second equation. So given the two equations, let us solve this. Let us add the two given equations. S sub n plus S sub n is equal to 2S sub n. A sub n plus a sub 1 is a sub 1 plus a sub n, or a sub n plus a sub 1. A sub n minus d plus a sub 1 plus d, our d will be cancelled, so the remaining will be a sub 1 plus a sub n. A sub n minus 2d plus a sub 1 plus 2d, our 2d will be cancelled, so the remaining again would be a sub 1 plus a sub n. And then we have a sub 1 plus a sub n, so we'll still have for the last terms as a sub 1 plus a sub n. So this is our new equation. Now, we need to simplify this. We have 2s sub n is equal to, as you have noticed, we have repeating terms here. So what we're going to do is we use n times the a sub 1 plus a sub n. And since we're looking for the s sub n, our 2 must be eliminated. We apply the MPE, or multiplication property of equality, to eliminate our 2. We multiply the whole given equation by 1/2. 2s sub n times 1/2, our 2 will be cancelled, so the remaining would be s sub n, equals n times a sub 1 plus a sub n times 1/2, so we'll still have n times a sub 1 plus a sub n over 2. Therefore, the formula in finding the arithmetic series when our first term and last term are given will be s sub n equals n times a sub 1 plus a sub n over 2. Or, it can be n over 2 times a sub 1 plus a sub n. Okay, what if our a sub n is not given? So let us use the same formula that we have used to derive another formula. So using S sub n equals n over 2 times a sub 1 plus a sub n, let us substitute the value of the a sub n using again the general rule of an arithmetic sequence. That is, a sub n equals a sub 1 plus the quantity of n minus 1 times d. So by substitution, we have S sub n equals n over 2 times the quantity of a sub 1 plus the value of the a sub n will be a sub 1 plus the quantity of n minus 1 times d. Now let us combine our a sub 1. That will be S sub n equals n over 2. A sub 1 plus a sub 1 is equal to 2a sub 1 plus the quantity of n minus 1 times d. Therefore, the formula for going to get the arithmetic series when a sub n or the last term is not given will be S sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. Let us have examples. Example number 1. Find the sum of the first 20 terms of the arithmetic sequence negative 2, negative 5, negative 8, negative 11, and so on. The given will be the first term or a sub 1, which is negative 2. Our d, negative 5 minus negative 2, this will become plus, this will be positive, so negative 5 plus 2 becomes negative 3. And our n is 20 because we are looking for the sum of the first 20 terms. What is unknown here is the sum of the 20 terms. So we have S sub 20. The formula to be used, since our first term, our d, and our n are given, and obviously the last term is not given, we will use the second formula. That is, S sub n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. Let us now solve. So by substitution, using our given formula and values, we have S of 20 equals 20 is our n over 2 times 2a sub 1, our a sub 1 is negative 2, plus we have 20 minus 1 times negative 3. So let us simplify this. We have 20 divided by 2 is 10. 2 times negative 2 is negative 4. 20 minus 9, 20 minus 1 rather, is 19 times negative 3. Then we simplify the terms given the parentheses or the grouping symbols. 19 times negative 3, and then you add it to negative 4. That becomes negative 61. And then multiply by 10, the answer will be negative 610. So therefore, the sum of the first 20 terms of the arithmetic sequence will be negative 610. Example number 2. What is the sum of the first 100 natural numbers? The given will be a sub 1 is 1, a sub 100 is 100, and our n is 100. Remember, when we talk about natural numbers, these are called as positive numbers. So the positive numbers will start from 1, and then we're talking about the sum of the first 100. So after 1 until 100, those are the first 100 natural numbers. That's why we have the first term and the last term as 1 and 100 respectively. And our n would be 100 because of the first 100 natural numbers. The unknown here would be the sum of the 100 terms, or the S sub 100. The formula to be used, since the given are the first term and the last term here, we can use the first formula. That is, S of n equals n over 2 times the quantity of a sub 1 plus a sub n. Let us now substitute. Using the values, we have S sub 100, n is 100, equals 100 over 2 times the quantity of the first term plus the last term, which are 1 and 100 respectively. Simplifying these terms, 1 plus 100 is 101. 100 divided by 2 is 50. 50 times 101, the answer would be 5,050. So therefore, the sum of the first 100 natural numbers is 5,050. Example number 3. How many terms should be added in the sequence 3, 6, 9, 12, and so on to sum up to 165? The given are the first term, which is 3, the common difference, 6 minus 3, 9 minus 6, 12 minus 9, which is equal to 3, and the sum, which is equal to 165. So what are we need to find? We need to find for the n, or the number of terms. How many terms should be added? So we're referring to the number of terms. So the formula in finding this, still be using the formula given a while ago. We'll have S of n equals n over 2 times the quantity of 2a sub 1 plus the quantity of n minus 1 times d. Let us now solve this. By substitution, we'll have 165 equals n over 2 times 2 times the first term 3 plus n minus 1 times our common difference 3. Simplifying this one, we'll have, since we have n over 2 here, we can multiply 2 by 165. That is by using cross multiplication or cross product. So 2 times 165 equals, the remaining here will be n. 2 times 3 is 6. And then this 3 will be distributed with our n minus 1. So 3 times n is 3n. 3 times negative 1 is negative 3. Then 2 times 165 is 330. Then before we multiply to n, we need to simplify the terms inside the parentheses. So 6 minus 3 is 3 plus 3n. And then n times 3n is 3n squared. And then n times 3 is 3n. So as you have noticed, we can form here a quadratic equation. That will be 3n squared plus 3n minus 330 because we need to apply addition property of equality or APE. We'll need to add negative 330 both sides. So this one will be cancelled and then we will add negative 330 on this side. That's why we have a quadratic equation or a second degree equation as 3n squared plus 3n minus 330 equals 0. But that is not yet the value of our n. We need to find a value of n by using any methods in solving quadratic equation. Remember, there are different methods. We can apply quadratic formula, we can apply completing the square, or by factoring. But before that, let us first get the common monomial factor of this given quadratic equation. Obviously, the common monomial factor is 3. That would be 3 times n squared is 3n squared. 3 times n is 3n, and 3 times negative 110 is negative 330. So we can have n squared plus n minus 110 times 3 equals 0, which is the same with the given quadratic equation. Now getting only n squared plus n minus 110 equals 0, let us find its factors. So we can use n minus 10 times n plus 11. So by using the FILE method to check if these are the correct factors, multiply the first terms, n times n, which is n squared, and then we have the outer terms, n times 11 is 11n, negative 10 times n, which are the inner terms, that would be negative 10n. So 11n plus negative 10n, that would be positive n, or 1n. And then negative 10 times positive 11 is equal to negative 110. So these are the real factors of the given n squared plus n minus 110 equals 0. Now applying the zero product property, we need to get the given value of n here. That would be n minus 10 equals 0 will be n equals 10. We add positive 10 both sides. That's why we have n equals 10. And with n plus 11, we'll add negative 11 both sides. Therefore, we have n equals negative 11. But remember, we are looking for how many terms. We're referring to the number of terms. And it is impossible to have a negative numbers. That's why we will only take the positive one. Therefore, there are 10 terms to be added in the sequence to sum up to 165.